Alright, let's have a look at problem 2272, substring with largest variance. So for this problem, we're going to provide a solution based on the Kadane algorithm, so which is a very classic algorithm. So essentially, it's a dynamic programming method. So first, I'll go through the statement of the problem and emphasize several points. Then we'll look at the method and the specific procedure. And finally, we share the code and comment on the main points. First, let's look at the statement of the problem. So the variance of a string is defined as the largest difference between the number of occurrences of any two characters present in the string. So note that the two characters may or may not be the same. So as a simple observation, if the two characters are the same, then they produce zero variance because they have the same occurrence or frequency for sure. So the question asks, given a string S consisting of lowercase English letters only, so we return the largest variance possible among all substrings of S. So in short, this problem asks us to return the largest frequency difference of two characters appearing in the string S or in any of the substrings. So a substring is a contiguous sequence of characters within a string. So that's the main statement of the problem. So here are two examples. Let's look at the first one in some detail. So this is the S, which has length 7. So the output is 3. So here is the variance 3 substring. So in this string there are 4 B's and 1 A's. So the difference of the frequency is 3. So in the second example, all the characters appeared with frequency 1. Therefore, the largest frequency difference is 0. So that's the two examples. The constraint, so S has length up to 10 to the power order 4th. So in other words, we cannot use pure brute force. For example, we cannot find all the possible substrings, right? So S consists of lowercase English letters. So this assumption or constraints plays an important role in our solution. So we'll emphasize it later. So here is some hint. So for example, we can check any two distinct characters and then return the maximal of the difference between them. So this is actually exactly the way we think of the problem in this solution. So now let's look at the method and the idea here. So the method is dynamic program. Here we are using a special version of Kadane's algorithm. So if you haven't used Kadane's algorithm before, I would suggest that you look at the problem Leetcode 53, so maximum subarray. So that's basically a standard use of Kadane's algorithm. So here, what we want to do is that first I'll transform this problem. So the overall idea is like this. So we will write a function that can detect the frequency difference for two characters. Then we just traverse all the possibilities of the pair of characters. So if we follow the hint, actually, for two characters A and B are just represent the two generic characters to examine. So we can assign them positive 1 or negative 1 respectively. Since all the other letters, let's assume they are 0. Then the problem reduces to find a substring with maximum absolute sum, right? So because the sum plus and minus counts the frequency difference. So here, but notice that if we use this method, so we need a substring to include both the two characters. Let's see, one called A, one called B, or else the variance is 0. In other words, if a string just contains a single character or contains characters which appears just equal number of frequencies, they result a variance 0. So here the procedure is actually the following. So we'll write a hyperfunction that is able to check maximal variance for any two distinct characters A, B. A can be any lowercase English letters and B can be any lowercase English letters. So then we iterate for every pair of A, B in the ASCII lowercase. So in this case, we just need to run the maximum, then we get the result. So here is actually a further detail in the code we wrote using the Kadane algorithm. This finer detail, we're going to come back this point. Here we write here just for saving your time. So here also an example of running our algorithm, or the variant of Kadane's algorithm. So you are also encouraged to have a try after seeing the full code. So with that said, let's do the real job. First, we'll write a function. So called let's write a hyperfunction. Define if hyperfunction. So I will call this function Kadane. So it's a version of Kadane's algorithm. So here A and B. So let me make some remarks. A and B are strings, string of the characters, lower characters, and what we return is the maximal difference, frequency difference. So here we assume that A appears more than B. So A, let's assume higher frequency, and B a lower frequency. So with this assumption, actually we can see this function will not be symmetric. In other words, Kadane AB in general does not equal to Kadane BA. Okay, so with that said, let's first do this function, and then in between we explain the logics. So overall, let's first look at the big picture, then we come to the final details later. So for this purpose, I'm going to first initialize a variable called answer, and also the count of letter A and the count of letter B. So let's call it 0, 0. Here I also want to introduce another variable, that is, can we extend to previous B. So here originally I will set it as false. So this can extend previous B actually corresponding to this finer detail, but you can check after the code. So what we want to do is that we just count the number of A's and B's and then update the answer in the process. And for this purpose, I would just iterate over S. So for character in S, if character does not equal to A and character does not equal to B, so we just continue. So this is the routine. So now basically we want to check if it's A or B. So we're going to increment the two variables, count A and count B, by 1. So if C equals A, we're going to count A, increment by 1. Otherwise, if C equals B, right, count B, incremented by 1, because we have already checked this condition. So the else part of this if is C either equals A or C equals B. If it equals A, we're going to count A by incrementing 1. And similarly, in other case, we increment B by 1. So with that side, so now in order to count the frequency difference between A and B, we need a substring to have both A and B. If not, actually, so the B or A itself can only produce 0 frequency difference. So here now let's do this. If cont b is greater than 0, in other words, we have a b, so we are going to update this answer by maximum of the previous state and the difference between the frequency of a and b so far, cont a minus cont b. So this is one case. So the reason is that we need b, both a and b, in order to compute their difference, or more precisely, we need at least one b. So with this if finished, let's do other cases. In other words, if cont b equals 0, and if we can extend to include 1b in the previous part, you can think of as a prefix. So if can extend to previous b. So in this case, I'm going to update this answer like this, the previous state, and then currently we have this number of a. Then actually we can add a prefix with b has one more count than a. In other words, we just need to count a minus 1 in this case. Prefix, or it can like this, imagine, or do this in the air. So that's the else part. So otherwise we're going to reset. So so if we have count b is 0 and also we cannot extend the previous ones, then we need to reset this state. So if count b is greater than count a, what we want to do is reset count a equals 0, count b equals 0, and reset the state. Can extend previous b to be true. The reason is that when count a and count b has this relation, that is count b greater than count a, then for each of the substring we see afterwards, if there are no b's inside, we can imagine that we prefix that string with a prefix which has one more count of b than a. So in this way, we just produced another substring which has both a and b, and we can maximize our frequency difference at that basis. So once we do this, actually we can return the result. So here, this part, this reset, and here the can extend b corresponding to here, to this finer detail. For example, if we look at here, so if we scan the string up to here, we have more b's than a's, but we want to compute the difference, frequency difference of a minus b, but here is negative, right? Then we reset and we look at the below the afterwards. So afterwards we have this number of a's, but we do not have b. So because we have already set, in this case, can extend to be true, then we can add this b or imagine this b. Then the overall result of this part, we will have 6a and 1b, so producing a variance 5, which is very large. So in the second case, again, up to here, b is number of b's is larger than number of a's. So then we reset, and then we look at this one. So we have 5 a's, and then we can add a b here. So then in this case, we are going to produce a variance 4. So in either cases, we can imagine that. So once the state is reset, so we can imagine or prefix in the air a string before this, which has at most 1b larger than than the number of A's, or in other words, so it contains A's and B's, so the number of B's in the prefix one more than A, or it's just one B, that's also okay. So that's the case. So here, I guess before we do the return, let's do some comments to help understand this one. First is that Kadane is not symmetric. So in other words, Kadane AB in general does not equal Kadane BA in general. So this is the one thing. The second is the finer detail specified above. So for the first item, so you can see here. So in this example 1, so if you compute Kadane A and B, the character A and the character B, so you're going to get 2. If we compute Kadane character B and the character A, we're going to get answer 3. So with that side, I guess we should have a better idea about this. Let's call this step 1. And then step 2 actually is rather routine now. So iterate over the pairs. So and also in this example, if a character does not appear in this string, for example, in this one we check for S, we check A and C, we're going to get 0 because C does not appear in the process. So in other words, we can never include enter this part. So with that said, I'm going to for this one we just use some ASCII letters from string. So import ASCII lowercase. So this string actually is nothing but A, B, C up to X, Y, Z, right? ASCII lowercase. So let's copy this. Then we're going to iterate. So answer is 0. Then for letters C1 in this ASCII lowercase, for C2 in ASCII lowercase. What we want to do, if C1 does not equal C2, we're going to update the result by calling the Kadane hyperfunction. So the answer is maximal of Kadane C1 C2. So afterwards we are going to return this answer. So that's the logic. So the overall structure is that we transform this problem by checking the absolute difference in frequencies for any pair of lowercase characters, and then the problem reduces it for a specific pair, how we compute the difference in the frequency. So with that said, let's do some check for examples. So int is not iterable. So here, let me add this answer. So yeah, this is for the first one. So let's so here is a specific run through of Kadane A and B. So Kadane AB gives 2, and Kadane BA gives 3. Let's do this check maybe here. Let's reverse this to verify our comments and also get more information for this. Kadane AB equals 2 as specified here, and Kadane BA equals 3, right? So with that said, why not do a check for example 2. This is a trivial case, I would say. What we get is 0. So with that said, let's check for the generic case. Oh yeah, it passes the generic case. So with that said, let's review the procedure again. So for this problem, essentially we are doing dynamic programming, and we're using an algorithm named after Kadane. So if you would like to see a vanilla use of Kadane's algorithm in a simpler setting, so Leetcode Problem 53 is a good place to start. So here is a final detail in item 6. So I would suggest you try to digest this part. So I will stay here for 1 or 2 seconds so that you can spot this part. So for example 1, here we wrote a detailed run-through about the state of the variables, and for contain character A and character B. So you can try walk through contain B and A to get 3. So that's all about this solution. I guess the video runs longer, so I guess that's about it. Thank you very much.